Hello, great science students. Welcome back. As always, we are here all day, all time, just to learn. All right. This is another amazing problem. It's simple, very easy, but we just have to keep learning in order to unlock all this. So it's not a day perfection. So you need to learn chemistry hard. So once you do that and understand it, so it becomes very easy. All right. The question says an element has atomic number of 14. All right. To which group in the periodic table does it belong? Right. Now we are given the atomic number of an electron. Right. The atomic number is given as 14. All right. So, and don't forget, this atomic number is same thing as your number of what? Number of proton. Is that not so? Now ask us the number or the group to which this particular element will belong to. All right. There are several ways of doing this. Okay. I will follow one of the as in the lengthiest and the hardest way that a lot of people might be scared of. So, and the particular second one, I'll need you to comment in the comment section. So to do this, I will be using the sub-level notations in order to unlock this problem. What is sub-level notation? I'll be using this particular number, which is same thing as 14. That's our atomic number, which is same thing as our number of protons. Right, and don't forget this element already is a neutral element. So, and in a neutral element, your number of proton will be equal to the number of electron, right? So, which is also equal to 14. I will now take this electron and fill it into the sub levels of this particular element, right? So, in doing that, I will have the electronic configuration, the sub level configuration of this particular element, and I'll be able to easily deduce the group in which this element is. Now let's start filling this electron into the sub levels. So we are going to start with the first one, which is 1s. So, and as you all know, s atomic orbital will accommodate 2 electrons because it has just only 1 orbital. All right, out of this 14, so this 1s will take 2. All right, secondly, now are we going to have any other one again? No, that's it. Our first energy level only has 1 atomic orbital. It has just only 1 atomic orbital. Now secondly, we are moving to the second energy level. In the second energy level, we are having our s orbital as well, right? We're having our s orbital, so 2s now. So our 2s will take 2 electrons out of this again. So we are left with 10 electrons, right? In that same second energy level, where n equals 2, we have another orbital, which is p orbital, right? The azimuthal quantum number really explain this, in the sense that whenever you have a particular energy level, right? So your azimuthal quantum number L is always n-1, right? Which means that if your n is 1, right, your azimuthal quantum number will be 0, which means you have just only one orbital available there. But when your L is equals to 2, you have 1 as your maximum value, which work. So but before that you have 0,1, which means you have 0 and 1. 1 is the highest value, which means you still have 0 in it, and 1, which means you have two possible atomic orbitals in there, which is your s and your p. Okay, now you move to 2p orbital now. So there is a particular rule that also explains why this 2s electron comes, 2s orbital comes before this 2p. All right, so the Aufbau principle, the principle of Aufbau really explain this one a lot, which just means that when you are filling electron into the sub levels, those orbitals with lower energy must be first filled before orbitals of higher energies are filled, right? And there's a particular nice diagram that traces it out. All of this will be covered in this class. You just need to follow, subscribe, and share, and share the gospel. That's it. All right. Now, here we have 2p out of what? Out of the remaining 10. So, and don't forget your p orbital can take up, it can easily take up 6 electrons. Oh, sorry, this marker is messing up. Okay, use this. So this can take up 6 electrons, right? Okay. Now 2 plus 2 plus 6, that's 10, right? We are left to work with 4 electrons now. Now we are going to the third energy level, which is 3s again. In the third energy level, we have the possibility of having 3 atomic orbitals. The first one here is 3s, and same thing. Your 3s will accommodate 2 electrons, right? Accommodate 2 electrons, while your 3p again, your 3p will just accommodate 2 electrons here. That's what left for this particular p. It should have accommodated 6, but the remaining electron is 6. Now what does it mean? It means that this is the energy of the first energy level, and this 2 means that this is the second energy level. First energy, the second energy. Why this one means what? The third energy level. All right. And what's the energy level means? The energy level are just what? They are the shell. They are the shells through which the electrons are orbiting around the nucleus. So the last energy level here, this is the last energy level, right? That last energy level tells you which particular group an element belongs to. Okay, now in the last energy level, the total number of electrons in the last energy level is equal to the group of the elements. Please take note of this. So it's equal to the group of the element. Now in this last energy level, how many electrons is there overall? We have 3s2 here, and we have 3p2 here, which means 2 plus 2. So the group number of this particular element will be 2 plus 2, which is equals to 4. But we normally write this group in the Roman numeral format. So we write it as this. Okay. Now, and again, this 3, what does it 3 means? That's the last shell. And it tells you the period in which the element belongs to in the periodic table. So the group is 4, while the period is what? The period is 3. Okay, there's the other one in which you just simply use the shell notation. So you can do that. It's very simple. Just do that and let us know your answer in the comment section. Thank you very much. You're welcome. Up to the next one. All right. Bye bye.